Ever stopped to think about how a program, which is really just a list of instructions, actually makes a choice? I mean, a computer is built to just do one thing after another, so how does it decide? That's exactly what we're going to dig into today.
It kind of feels like a paradox, doesn't it? A computer just plows through commands one after the next. So where does the thinking, the logic, the whole if this happens, then do that part come from? Well, let's pull back the curtain on that. The magic trick here is a concept called control structures. You can think of them as the traffic signals for your code. Instead of your program just blindly marching down a list of commands, these structures let it pause, check the situation, and then decide which road to take next. Okay, so let's start with the most fundamental control structure of them all, the mighty if-then-else statement. This is like the absolute bread and butter of all digital decision-making. At its core, even the most complicated logic often boils down to a bunch of simple binary questions. Is the user logged in? True or false? Is the number greater than 10? Yes or no? It's always this way or that way. So here's how it works, broken down. First, the program tests some condition that can only be true or false. If it's true, boom, it runs the then code. If it's false, it pivots and runs the else code instead. It's a simple but incredibly powerful fork in the road. And this is what it looks like in its formal grammar, sort of the universal blueprint that all programming languages use to understand this idea. Don't let the syntax fool you, it's super simple. You just give it a logical test, a then action for a true result, and an else action for a false one. Simple as that.
Okay, so a single choice is powerful, for sure, but the real world is messy, right? One decision often depends on another, and that's where we get into nesting, putting decisions inside of other decisions. Now take a look at this. We've got an if statement tucked right inside another one. It looks harmless enough. You just make one choice, then you make another. But this simple-looking structure is actually hiding a classic trap in programming. So here's the million-dollar question. Who does that else belong to? Does it go with the first if or the second inner if? Because depending on the answer, the logic of your program could be completely different. This little puzzle is famously known as the dangling else problem. Now, to avoid that kind of chaos, programming languages have a very strict, non-negotiable rule. It's simple. An else statement always pairs up with the closest if that doesn't already have its own else. This one rule just completely eliminates the ambiguity and makes sure the code is predictable, every time. All right, so we've got the two-way path down. But what happens when you have way more options? You're not just choosing between yes or no, but maybe between A, B, C, D, or E. So one way to handle this is the if-else-if ladder. It's just a chain of if-else statements, one after the other. Like if the user's choice is 1, do this. Else if it's 2, do that. Else if it's 3, you get the picture. It works perfectly, but you can see how this could get a little messy and hard to read if the ladder gets too long. But there's often a much cleaner, more elegant way to do this, the switch statement. It's purpose-built for this exact situation. It looks at one expression, then it literally jumps straight to the matching case and runs the code there. It's usually much easier to read and often more efficient too. So if we put them side by side, you can really see the difference. The if-else-if ladder is like a Swiss Army knife. It's super flexible because every condition can be totally different. The switch statement is more like a specialized tool. It's incredibly clean and clear, but it's designed for one specific job, testing a single value against a bunch of options. Okay, so let's zoom out for a second. Remember that dangling else problem we talked about? Well, it's not just some weird random quirk. Understanding it actually helps us see the much bigger picture of how programming languages are designed. The official, fancy term for that dangling else issue is ambiguous grammar. And it's a huge no-no in programming. Why? Because a computer demands absolute clarity. It can't guess what you mean. If a statement can be read in two different ways, that's a recipe for disaster. So how do they fix it? Well, language designers are really smart about this. They build specific rules right into the DNA of the language to eliminate any confusion. That rule about an else pairing with the nearest unmatched if, that's a perfect example. It forces one and only one correct interpretation. So what you've got to realize is that all these strict, picky syntax rules aren't just there to annoy you. They are the absolute bedrock of reliability. They are the guardrails that guarantee that the logic you think you wrote is the exact same logic the computer is going to execute. No surprises. And really, it all comes down to this one question. From a simple if-else statement all the way up to the complex grammar of an entire language, everything is designed to get rid of ambiguity. Because if the very tools we use to build logic are shaky and uncertain, how can we ever trust the solutions we build with them?